Welcome to the fourth of 8 videos for Chapter 3, Basic Sentential Logic, Informal Fallacies, and Cognitive Biases. In this video, I'm going to be introducing the last 2 inference rules. So the first 4 that we've introduced in previous videos, there's sort of an organization to them. Now that's not on purpose, it's not necessary, but just in fact the way it's worked out, the way in terms of the rules we're going to use in this course in Chapter 3. We have 3 two-place operators. There's conjunction, disjunction, and conditional. And we have 2 rules for each one. So far we've introduced 2 rules for conditional, modus ponens and modus tollens. We have 2 rules for disjunction, disjunctive syllogism and disjunction introduction. And now we're getting 2 rules for conjunction. Now, like I said, this isn't any necessary feature of how these inference rules work out, that there's 2 per operator or anything like that. It's just how it's, in fact, working out in terms of the rules we're using in the core material for the course. But it is a good way to memorize them. We have 6 rules, and there's just 2 for each operator. So if you're trying to remember all 6 rules, just think there's going to be 2 for disjunction, 2 for conditional, 2 for conjunction. And now we're doing the 2 for conjunction. So the first rule is simplification. And what this rule says that if you have a conjunction on a line, you can write a new line that just consists of either conjunct by itself. So if I have alpha and beta, I can just take the second conjunct by itself on a line. I could also do the first conjunct by itself, either one. The rule of conjunction says that I can write a new line consisting of a conjunction where each conjunct is just a statement that's already up here somewhere. So you can think of it roughly as like I can take any 2 statements and I can combine them into a conjunction if I want to. Okay, let's see some examples. Here, there's no conditionals on lines by themselves, so I can't. Modus ponens, modus tollens are out. You can always use di, remember, as long as you have something, and we have 2 premises. I could use di, but there isn't any obvious way di is going to help me. I can't do ds. I have a disjunction, but I don't have the negation of either disjunct. What about the 2 conjunction rules? Well, I could use conjunction and just combine these. So I could go line 3 would be a conjunction where this is one conjunct and that's the other conjunct. It'd be this really big, long conjunction. I could also, this is a conjunction, I could simplify these 2 conjuncts off because maybe these would be useful. So I'm going to go ahead and do that. I'm going to use the rule of simplification. First, to simplify the first conjunct off on a line by itself, line 2 simplification. And then I'm going to get the first conjunct, not D, on a line by itself. Why did I do this? I don't know, just because I could. There wasn't anything obvious that sounded like a great idea. So, and if you don't know what to do and you've got a conjunction, sometimes just simplifying the 2 conjuncts off can help. Now you might have also done it with a certain plan in mind. You might have realized, hey, I've got a disjunction. If I had the negation of this disjunct, I could do ds. Negation of that disjunct is here. Now you have to get it on a line by itself before you can use ds, and we got it. We got it on a line by itself right here. Well, that means I can now do ds on 4 and 1. I have a disjunction, negation of the first disjunct right here, so I can derive the other disjunct. If E, then not G. And that's by 4-1 ds. Now what can I do? Well, this other conjunct that I simplified off turns out is going to be useful because look, this is the negation of that consequent. So I could do modus tollens to get the negation of the antecedent. And then I'm done because that is the conclusion of the argument I wanted. Okay, so you can see here that simplification can be useful because both of these conjuncts by themselves were crucial, but when they're together in a conjunction, you can't use them, right? I can't use not D for DS while it's still combined into this compound statement. And I can't use G here for modus tollens, right, while it's part of this compound statement. But once they're on lines by themselves, you can use them. So simplification can be useful in that respect. Let's do another proof. There's a number of things we can do if we're just looking at this and thinking, hey, what are the possibilities? I've got a disjunction, and this is the negation of the first disjunct, so I could do DS here. I've got a conjunction, so I could simplify these conjuncts off on lines by themselves. There's what else could be done? It's the only thing coming to mind. Of course, you can always use conjunction. I could decide, hey, I want to make a conjunction that has D as a conjunct and this as the other conjunct. And remember, you can also always use DI. I could always just create a disjunction that has any of these as one of the disjuncts and something else as the other disjunct. But I'm going to go ahead and I'm going to do simplification. I'm going to get this on a line by itself. So line 2 simplification. I could also get not R on a line by itself, and that might come in handy later. Maybe I'll do it. I don't know. Next, I'm going to do DS. Remember, the other thing I said I could do is I have a disjunction. I have the negation of the first disjunct. I can derive the second. Why not? At this point, what I'm doing is what's a usual strategy for approaching proofs, what I've done so far, which is just apply the rules and hope good things happen. As we'll see, sometimes you can actually have a strategy beforehand. Before you even start the proof, you could look at the conclusion, you could try to work backwards and see how to do the proof before you even start. That's fine too, but for now I'm just applying the rules where I see they can be applied. I could also simplify off not R if I wanted to. But instead, what I'm going to do is I've noticed now, I'm looking at this, here's another place I can apply a rule. This is actually the antecedent of this conditional, if H then not J. So I could get the consequent by modus ponens. So I'm going to go ahead and do that. Now I'm looking at this and thinking, hey, this is a conditional. Consequent is R. If I had not R, I could do modus tollens. Remember, not R was one of the conjuncts up here. So now I think, oh, it would have been cool if I had simplified this one off up here, but it doesn't matter. I can simplify it now that I realize I can use it. So I'll simplify not R from line 2. And now I can do modus tollens, right? I have a conditional. I have the negation of the consequent. I can infer the negation of the antecedent. Now what? Well, there's a number of things we could do here, maybe. At this point, I'm going to look back at the conclusion. I'm going to see if there's any obvious way that I can just get not J. How could I get not J? Well, one place it shows up is right here. This is cool. If I could get H, then I could get not J by modus ponens. That's great, because that's pretty simple. It also shows up, well, that's this, and that's that. Yeah, so J, oh, if I could get R and D, also, here's D. If I could get R on the line by itself, then I could get R, I could conjoin it with D, the rule of conjunction, and get not J by modus ponens. If I can't figure out how to get H, maybe then I'll try to figure out how to get R. Okay, but it turns out I can get H. Look at this for a second and see if you can figure out how we can get H. Hint, look at line 7. It's a disjunction, right? H or H. I have the negation of one of the disjuncts. Now, in this case, it could be either one. I could conceive of this as the negation of the first. I could conceive of it as the negation of the second. It doesn't matter. The point is, I can use 10 and 7 with the rule of ds to get H. I have a disjunction. I have the negation of the first disjunct, so I can derive the second disjunct on a line by itself. Okay. Now that I have H, I can get not J by modus ponens. Okay, the proof is done, but now I want to look back at this proof because there's a couple of things that you might have you scratching your head. One is, hey, look, we managed to get two statements that contradict each other. We managed to derive not H on a line and H on a different line. Isn't this a problem? Well, is it a problem? So we did manage to derive two statements that contradict each other. What could that mean? Well, maybe one thing it could mean is maybe we just made a mistake somewhere. Maybe we used a line wrong. That's one way. If you derive something puzzling that you don't think you should have been able to derive, that's one possible explanation, is maybe you made a mistake. Here, there is no mistake. So that's not the explanation for what's going on. Think of it this way. Why is that? Why does it trouble you? Why might you find it troubling that you could derive both of these? Well, you might find it troubling because you'll think, hey, these are contradictions, or these are contradictory. They can't both be true. That's right, and that's interesting. If 10 is true, 11 has to be false. And if 10 is false, 11 is true. So we know these can't both be true. Now you're thinking, there we go, that's the problem. Rick, you said, way back in the second video for chapter 3, you said these rules are truth-preserving, which means that if the stuff we're applying them to is only true lines, we can only produce true lines. But we managed to produce something false. Now, we don't know which one of these is false, right? But we know these can't both be true. Okay, if this is true, that's false. And if this is true, that's false, right? So either way, we know we've derived something false. How is that possible with truth-preserving rules? Well, it is possible, but it's only possible, there's only one thing that makes it possible. The stuff we were applying the rules to can't have all been true. Or to put it another way, the premises are inconsistent. These premises can't all be true at the same time. Now, if the stuff we apply rules to aren't all true, then all bets are off. Those rules might produce true lines, they might produce false lines. Remember, truth-preserving only guarantees that we'll produce only true things in the condition where the stuff we're applying it to is all true. But it makes no guarantees what will happen if you're applying it to things that aren't all true. And in particular, if you do a truth table for these premises, you'll see that they're inconsistent. Is this a problem for the proof method? No. Why? Well, we did manage to derive the conclusion, and the premises are inconsistent, so we know the argument's valid. Any argument with inconsistent premises will be valid. So if the premises are inconsistent and you derive the conclusion, you still know the argument's valid. Okay, so that's why it's not a problem. All right, that's enough for this video. Next up, we've got all of the inference rules. So for the core material, there's 6 inference rules. We have 2 that use conditional, 2 that use disjunctions, and 2 that focus on conjunctions. In the optional material, there's a couple more rules. But we've got all of the core rules down. The next video is going to be some fine-tuning because there's some mistakes that students often make when they're doing proofs. 2 kinds of mistakes. Sometimes there's things they do that they shouldn't do. And then sometimes there's things that they can do that they didn't realize they could do. So I'm going to have a video sort of walking through some of those things just to help fine-tune everybody's proof technique, and that'll be up next.